and I thought, I'm going to share this with my students. So, let me write down the original problem first of all. Why is that kid hovering out there in the hallway? The original 230 minus 220 times a half, is that what it was?
Yeah.
Okay. And so, if you had to look at the problem very carefully, because it said, what did it say?
The answer is 5.
Okay, but the part that you
Equals
overlooked
Y.
maybe was it said the answer is 5 with an exclamation point after it. So when you did the math, of course you get PEMDAS, at least I hope you would do that, and you ended up with 120 as your answer, right? And that is 5 factorial. What does 5 factorial mean? 5 times 4 times 3 times 2 times 1. So the tricky part of the problem was that the exclamation point wasn't really an exclamation point for the sentence, it was actually part of the answer, right? Okay. The other two things I need to talk about is this always makes me so mad when I screw up stuff that I get mad at you for screwing up for, but I screwed it up. So I need to figure out, yesterday I made a mistake. And I need, here it is. So find the sheet we did yesterday, problem number 3. The sheet we did yesterday, problem number 3. It was one of the true false things. One of the true false things. And I'm always harping at you about reading the problem carefully. And I did not. Problem number 3 on the the sheet that we did yesterday, the 2-pager. The sheet we did yesterday in class. Problem number 3, the last true false. In number 3. The average rate of change is decreasing. That means the slope, the average rate of change is decreasing. I was looking at slope. I was not looking at what I should have been looking at, which is what? Concavity. I should have been looking at concavity because I'm talking about the rate decreasing, the rate of change. So the answer, so if I look at the interval from 0 to 3.5, that part of the curve is clearly concave down. Would you agree with me? And if it's concave down, that means its rate of change is decreasing. That's a true statement. That's a true statement. So sorry about that. I'm all the time getting after you for that kind of mistake, and I made it myself. I've got to read more carefully. The other thing I want to do before we start taking your questions, the other thing I want to do is another one of the big graph problems where you start with an equation and you have to come up with all of the poles and asymptotes and all that and sketch it. So if you've got a spare sheet of paper somewhere, let's get out that spare sheet of paper and let's graph and list all the important information. This equation right here. This was the last thing that we did yesterday. It was there's a lot of parts to the problem. It isn't necessarily hard, but there's a lot of parts to it. So I thought it would be good if we practiced another one. All right, we okay? So how are you going to start? What are you going to do first? Your job is ultimately to graph this. So what are we going to do first? So the bottom's kind of easy. What about the top though? Group it, okay. So I'm gonna have 2x squared, x plus 2. Please don't let me make any more mistakes. Minus 18.
Lock in, Mrs. Ford.
X, I'm trying. Does that look okay? So I'm gonna do my denominator in a minute. That'll be x plus 2, 2x squared minus 18, and then what? I
X
can,
minus 4.
yeah, I'm doing the top still. I can go farther with that, right? I can take out a 2 and be left with x squared minus 9. So ultimately, my numerator is going to be 2x plus 2, x minus 3, x plus 3. Would everybody agree with that? Is that okay? And then the bottom, as you've already pointed out, is going to be minus 4 plus 2. Right off the bat, what do we notice? There's gonna be a hole. I'm erasing some of this stuff here. There's gonna be a hole, and the hole is gonna be at -2. And my remaining problem is going to be 2x minus 3x plus 3 over x minus 4. Everybody good? So how do I figure out the rest of my hole? Plug in -2 right here. So that's gonna be 2, -5 and 1, and -6. How does that look? So is that positive? Yeah, so positive 5/3. I'm just gonna come over here and plot that right now. So -2, so -2 5/3. Okay, perfect. All right, what's some other stuff? Remember, this is where I'm now looking.
Vertical asymptote for 4.
I have a vertical asymptote at x equals 4. Everybody okay with that? Okay. What else? Not gonna have a horizontal asymptote, but I will have a slant asymptote. How do I know? Power on top is 1 bigger. Okay? So how am I gonna find my slant asymptote? I'm gonna divide, and I'm gonna divide my numerator by my denominator. Okay? This numerator by this denominator. So that's going to be, is that 2x squared minus 18? Divided by x minus 4. So when I do that division, don't forget to put the 0 in there. I can't remember if we talked about that or not. When you do synthetic division, if there's something missing, would you agree I have no x term? You have to put a 0 in. You remember that from your past? All right, so here we go. Don't care about this, that's not important. What is my slant asymptote gonna be? Y equals 2x plus 8. Everybody okay with that? So I'm gonna go ahead and graph that line now in my picture. I'll graph it with a green line. Okay, so that green line is y equals 2x plus 8. Would everybody agree with that? Okay? All right, do I know anything else? I think there's some other stuff I know about my picture. I know my intercepts, so do I have any x-intercepts? I actually have 2 of them, 3 and -3. Remember, the zeros of a fraction are always going to come from the numerator. So -3 and 3. And how about a y-intercept? Do I have one of those? Now be careful. The y-intercept of the asymptote is 8. I want the y-intercept of the thing in the box. So how am I going to find that? Put 0 in. So if I put 0 in, it looks like I'm going to get 18 over 4, 9 halves. Double check my math there. I don't want to make another mistake. Now, on the review page, it said list all the intercepts. We have them, we didn't list them, but we have them in here, right? All of our intercepts. Then it says list all the holes. Well, we've got that. We had one right here, right? And then it said list all the asymptotes. We have those in our picture, right? Everybody good? Then it says sketch. So at this point, we need to be able to figure out what this looks like. And I always want you to remember the vertical asymptote is the division. There's going to be something, you're going to draw some kind of thing over here, and you're going to draw some kind of thing over here. Okay? So, if this is my split, then I think the left side's pretty obvious, don't you? The left side, you got a whole bunch of stuff over here. So if I just connect all those things, and remember that I'm going to go closer to my asymptote the farther I go. Would that be okay with everyone? So that's the left side of the picture. Now we got to figure out what's going on the right side of the picture. Well, what do you think? It's that little tiny thing up here. How do I know? I could always plot points. Remember, if you're ever confused, stick some numbers in. But how do I know that has to be what it looks like? There's no other intercepts, right? So we can't be doing anything down here because it doesn't cross the x-axis. So all the action has to be up there. Everybody okay with that? All right, I thought that is that incorporates a whole bunch of stuff.
How many of those do you think you would have on a quiz?
One.
Just one.
One. Now, there could be other questions that ask specifically about holes or ask, but there's only going to be one when you have to graph the whole thing. Okay. All right. Because if you know how to do it, you know how to do it. All right.
There's a question that was asking for a horizontal asymptote, but there wasn't one, but there was a slant one. Would you want us to?
I would want you to write the same asymptote. And again, that's another one of my deficiencies. I shouldn't have ever referred to them as horizontal asymptotes, but I do. I can't help it. They're end behavior asymptotes. End behavior asymptotes will be horizontal when either the powers match or the one on the bottom is bigger. The end behavior greater asymptote will be something else if the power on top is bigger. So cross out the word horizontal, write slant.
For a question like that, and when you have to list all the intercepts, how do we write those? It's like line.
Points.
Points.
Yeah, so 0, 9/2. Intercepts are points on the graph. All right? All right, so speaking, let me turn some homeworks back because we're going to answer questions about everything. So hopefully you found some questions. Who found a question for us to start with? Yep, we'll start with you, Fred.
Can we do question number 4 on the back of homework 1?
Yep. We get these passed back, and then absolutely, so get out your homework, what did you say, 1.7? Which I think I turned back, but maybe I haven't.
These are not all week.
And Owen's out today too.
Just
getting
getting
college
class.
thing.
Yeah. Still miss Monday. He's pouring.
All right, so I'm looking at homework 7, 1.7, and it's problem number 4. All right, let's see what it is. 1.7. Number 4. Which of these have a slant asymptote parallel to this line? Okay, so Fred, we know that parallel means same slope, right? So 4x minus 3y equals 9. We have a slope of 4/3. Okay, so I'm gonna look at all of these options, and we have to have a horizontal, oh, no, excuse me, we have to have a slant asymptote parallel to that. All right, so look at problem A. Problem A, there's a 4/3 in there, but that isn't a slant asymptote, that's horizontal because the powers match, so that's out. Let's look at D. Same reason. There's a 4/3 there, but that's horizontal, so D is out. Oh, I went across, sorry. B. Oh, wait, look, B. Does B have a slant asymptote? Yes. And when I do the division, the ratio of 4x cubed over 3x squared is going to be 4/3 x. Now, that doesn't mean that that's the asymptote, but it's 4/3 x plus 5 or something. Does that make sense to you?
Yeah.
So definitely B is one. Let's look at E. Is E going to have a slant asymptote? Yep. And the same thing's going to happen. It's going to be 4/3 x. So that one's parallel. Look at C. Is C going to have a slant asymptote? No. Its asymptote's going to be quadratic because the power on top is too bigger. So C is out. And then F. Well, F, the power on bottom is bigger, so F's going to be 1 equals 0. So it should be B and E are the two. Does that make sense to you?
Yeah.
Okay. Anybody else have a question about either something in the big review packet of worksheets I gave you, or a homework somewhere, or something else somewhere? All right, we'll start with Mary Kate.
Could you go with 4A on 1.11?
111. 111, 4A is one of these where I have to write my own equation based on what I've got there. So, alright. Start with what I know I have to have in here. It looks like I have to have a vertical asymptote at -1, which means my denominator must have an x plus 1. I have a horizontal asymptote at 3, which means, first of all, however many parentheses I have up here, I'm gonna have down here, but there's gonna have to be an extra 3 up there to make that come out to be 3. It looks like I have an x-intercept at, what is that, -3. So I have to have an x plus 3 on the top. Are you with me there? And then it looks like I have to have a hole where? Where is that? I gotta count over. 2, comma, 1, 2, 3, 4, 5. So there's gonna be a hole at 2, 5, which means I have to have an x minus 2 on the top and the bottom. So that, I know that's the stuff I have to have, right? To make this even remotely work. So, if I cancel out that, now that has to remain in my final answer, but for purposes of figuring out my hole, I'm not gonna have that in there. So I put in 2, what do I get? 3 times 5 over, does that work?
Yes.
Yep. So then the last thing I should check is my equation giving me the curve going this way like it's supposed to? Now my gut feeling is absolutely, because that hole worked, but I could plot a couple more points just to be absolutely sure. Does that make sense?
Yeah.
Okay. All right, Alex, you had your hand up?
Can we do, on 1.9 and 1.10, can we do 1A, 1C?
1A, what am I doing here? I'm finding vertical asymptotes. I'm gonna go ahead and factor the top. So the top is gonna factor like that. And does the bottom factor? No. In fact, can that denominator ever be 0? No. So therefore, there are no horizontal asymptotes. Because why do I have horizontal asymptotes? A 0 in the denominator. Can't do it. Does anything cancel in that problem? No. So this problem has no discontinuities. Alright, it's gonna behave weirdly, it's gonna have a horizontal asymptote, but it isn't going to have any discontinuities. Alright, Alex, you good with that one?
Yeah.
Alright, and then you said C. So
Yeah.
C, I'm gonna take out a 3. That problem's gonna reduce just to y equals 3. There is a hole. The hole's gonna be at -1, and it doesn't matter what x is, for this line, y is always gonna be 3. So when I put in -1, I'm gonna get 3. Y equals 3, remember, looks like this. So at -1, it's 3. At 10, it's 3. At -7, it's 3. It's 3 all the time. So there is a hole, but there is no vertical asymptote because there's nothing left to. So that picture would look like this. It would just be a horizontal line with a little gap in there, one right there. All right, Sophia?
Can you do number 1 on 1.11, like the one you just said?
1 number one, what is the domain?
Yeah.
Alright, so the first thing I have to do is factor everything, cause I gotta figure out, actually, I'm not graphing it, so I really don't have to factor the top, I really just need to factor the bottom. Because when I'm talking about domain, I'm talking about what gives me a 0 in the bottom. Now, potentially, that could cancel out with something in the numerator, but it would still make a 0 in the original problem. Does that make sense to you? So I'm gonna factor my denominator. So my denominator is x plus 1, x plus 2, x minus 4. Did that make sense to you? Did I do that too fast?
Yes.
Okay, so whatever x is, x can be anything except those guys right there. So x can't be negative 2, it can't be negative 1, and it can't be 4. So it can be everything else. I'm doing domain now, I'm not solving anything, I'm just doing domain. So negative infinity to negative 2, negative 2 to negative 1, negative 1 to 4, and 4 to infinity. That would be my domain. Basically everything except those 3 points. Does that make sense?
Yeah.
Okay.
Can you do number 6 on them?
Okay, number 6 here. Says I'm expanding 2x plus y to the 4th. Have you watched the video, Gus?
Part of it.
That's not good enough. I'll do that
Gus
problem for
did.
somebody else, but not if you haven't done your part yet. Mark?
Could you do 2A on homework 1.9 and 1.10?
All right, 1.9, 1.10. I will happily do any problem for anybody who's either been in class or watched the video. Which one am I doing?
2A.
2A. Here's the problem.
This is cool.
What?
On your last problem, how is that x squared minus 4 not x minus 2x plus 2?
It should have been. That's what I meant.
How is it?
So, you guys, you can't just sit there. Thank you, Iman, for figuring that out. I've tried to do too much in my head and it didn't work. So that should have been x plus 2, x minus 2. Absolutely right. Okay, all right. Now what am I doing here? Obviously, there's going to be a vertical asymptote at x equals 2. So what I'm trying to figure out is what happens as I approach 2 from each side. That's what this means. What are my options if 2 is a vertical asymptote? My answer is either going to be what? Positive infinity or negative infinity. So basically, what am I trying to figure out? As I come in this way, am I going up or going down? So an easy way to check would be just to pick a couple of points on both sides. So if I put in 1, positive 1, what do I get? 1 would give me, is that 4? So 1 gave me 4. And then 0 gives me 1/2. Doesn't 0 give me 1/2? So what does it look like is happening over here? Looks like it's going up. So on this side, as we approach 2 from the left, it seems to be going up. And then over here, if I do the same thing, maybe plug in 3. 3 gives me a negative 4. And then plug in 4. That gives me a negative 1/2, so it looks like that one is going down. Remember, as you approach a vertical asymptote, you're either going up or down. That's your only choice, so you just,
Can you do number 3 on 1.11?
answer. 111, number 3. Find the slant asymptote. This one is not gonna be done with synthetic division because that's a quadratic in the bottom and it doesn't factor, so there's really no chance of enhancing anything. So I'm just gonna say my job is to find the asymptote only. I'm just going to divide. So, I have to do it with long division. Okay, does that look okay? So I say to myself, how many times is x squared go into 2x cubed? In other words, what's 2x cubed over x squared? What does that equal? 2x. I'm gonna put a 2x right here. Now, you can put it anywhere up there. I'm anal and like to keep things lined up, but just put 2x up there somewhere. Now, 2x times x squared gives me 2x cubed. 2x times negative x gives me negative 2x squared. And 2x times negative 1 gives me negative 2x. You still with me, Fred? Now, remember when you do regular long division, like you were dividing 5 into 19, you put a 3 up here, and then what would you do? Subtract. So I have to subtract this. That goes away, because that's how you planned it, for that to happen. So I have negative 2x squared plus 7x plus 1. I'm bringing 1 down. Now I start all over again. I've got an x squared, I need a negative 2x squared, so minus 2. So minus 2x squared plus 2x plus 2. Now, I'll go ahead and subtract, although this part isn't really necessary, but I'm gonna go ahead and subtract. Those go away, and I have 5x minus 1. Now, that's my remainder, because this is bigger than that. So it's like over here, this is bigger than that, so I'm done. That's my remainder, same thing here. So my slant asymptote is right there. How did I know in problem 3 on that thing I just did, how did I know there was even gonna be a slant asymptote? The power on top was 1 bigger than the power on the bottom. Right? All right, who else found something, either in homework or on some worksheet somewhere?
On the worksheet on page 6, can you do, let's see, can you do number 4?
Page 6, number 4. All right, determine if the following rational functions have a horizontal slant or neither. So problem number 4. Am I looking at the right one?
What?
Am I looking at the
Yeah.
right problem? Okay. So, when I look at this, determine, doesn't say find it, it just says determine if it has, what kind of asymptote it has. So what am I looking at? The degree. So I have x to the 4th over 2x cubed. Will that be a slant asymptote? It's going to be a slant, and the slope of that slant will be 1/2. Yep. And in order to find it, I'd have to do long, hideous long division.
I thought you were supposed to find it, that's why I was asking.
Yeah,
but
that would be like that problem on steroids, right?
On the like 1.7 packet we have, there's number 2 on the first page.
You mean this big packet where the pages are numbered? So page 1,
Yes.
number
2.
2. Page 1, number 2. Does it have a horizontal asymptote?
It has this one.
Yeah, it doesn't have a horizontal asymptote, but it does have a slant asymptote. And it doesn't say to find it, but we'll go ahead and find it because that's what Fred wanted to do. And this problem is more manageable. So we'll go ahead and find it. How are we going to find our slant asymptote? We're going to have to divide. And it's going to be long division. Would you agree with me? And it's going to be ugly, but we can do it. So here we go. What do I need? I need to get from here to here, so I'm gonna need to multiply by what? 1/5 x? So that's gonna give me x cubed, 7/5 x squared, and 8/5 x. Now, the good news is, remember, we only need to do one more step, because we only need to know what goes right there, right? So now I'll subtract. So what is that, 3/5? Please keep your eye on me, people. And minus another 3/5? Am I wrong? Tell me, stop me now. That's 10/5 minus 7/5. That's 5/5 minus 8/5. I think I'm okay. Now, what's gonna have to go up here? Well, I gotta turn that into that. So what am I gonna multiply to make that happen? 3/25? Alright, let's just check that. What's 3/25 times 5/1? And then you don't even need to do any more, because as soon as you're sure, that's what you're gonna get right here. Everything else is gonna be the remainder, and you don't need it. So if you had to find the slant asymptote, that would be it. Alright, so that problem, I know there's messy arithmetic. You understand the fundamentals of the problem, you understand what you're doing. Don't get bogged down in the arithmetic. Alright, who else found something? Yep.
On the 1/9 or 1/10,
Which one?
1D.
1D. 1D says find vertical asymptotes and holes. So, oh, and I don't even need to factor it because it's already factored. So I just need to cancel. So that will cancel. And that will cancel. So it looks like I'm left with x minus 1 over x minus 2. Is that what you see? All right. Tell me about a vertical asymptote. This problem has one. What is the vertical asymptote? X equals 2. No matter what, x can't be 2 in this problem. Now, in the original, x also couldn't be 1. But can x be 1 in this problem? Yeah, it can. If you plug 1 in, do you have a denominator? Yeah. Your numerator happens to be 0, but you can plug it in. When I say can you plug it in, I mean, do you not get 0 on the bottom? That's your issue, getting 0 on the bottom. Okay, so we talked about this the other day. If you have a hole, that means you cancel, because the only way to get a hole is to cancel something out. But just because you cancel doesn't guarantee a hole. We canceled out a 2, but we still can't plug it in. So it's not a hole, it's a vertical asymptote. Okay, does that make sense? Remember, if you have a hole, you have to be able to come up with a y coordinate. As long as you can come up with a y coordinate, you're all good. But if you have a 0 on the bottom, that ain't gonna work. All right, who else? Yep, Mary Kay?
This is like not over the math, but for the one that we did the long division on, it's asking, like since that one was just asking for horizontal, you would just say no.
No horizontal.
Okay.
And just to cover all your bases, you might just add in parentheses slant asymptote,
Okay.
because it's not horizontal, so that would be no horizontal.
And that review packet, can you do on page number 2,
Problem which one?
number 9?
So problem 2, number 9. So this is page 2. On the review packet, page 2, problem number 9, the one that says where is it positive? Fred, h greater than or equal to 0. All right, so the picture is drawn for you. Here is where h equals 0. This is where it equals 0. The problem says, where is it greater than or equal to 0? So I want all parts of the graph that are either touching this or higher than it, okay? So when I look at that, it looks like from -2, or I should say from negative infinity to -2. Would you agree with that? And I'm gonna include that -2 because that's an or equal to. Now where else? It looks like between -1 and 0.
So even though it looks like the line crosses the horizontal asymptote, it's still part of the answer.
It is. Remember, crossing a horizontal asymptote is not an issue. Okay? Remember, there's really only asymptotes out here. We draw them all the way across, but in the middle it's not an asymptote. Okay? So, we got a 0 at 0, and then we got a vertical at -1. And then it looks like we're also above 1 on. How does that work? Does that seem reasonable?
Should the 1 be a closed bracket?
This one?
Yeah.
Okay, it's gotta be open because 1 is actually a vertical asymptote. These guys are closed because they're zeros. They're x-intercepts. That is an asymptote, never gonna be a vertical asymptote.
Oh, yeah.
All right, these are great questions. Who else? Yep.
On the first page of the worksheet,
Number 10. Says write limit statements for the end behavior of the following rational equations. Now remember, limit statements for end behavior means what's the limit as x approaches infinity? And what's the limit as x approaches negative? This is end behavior. End behavior is what happens at the ends. Okay? Now, tell me about the end behavior asymptote of this problem. It's a 2x cubed, I'm doing number 10, right? It's a 2x cubed over a 6x cubed. So whatever this problem looks like, it has a horizontal asymptote. Where? At 1/3. Now what does that mean? I don't know what it looks like, but I know as it goes off the page, it's getting closer and closer to 1/3. So these are both 1/3. Now, if I had the picture drawn for me, then I could tell you, okay, is it coming in from the top or the bottom? But without having the picture, you're not required to draw the picture. You're just gonna say 1/3. End behavior asymptote is the end behavior of the picture.
Is it just if you have a horizontal asymptote, or is it like infinity as well? You don't have to.
Yeah, it's always. So if we had, I don't see it on there, but if we had a problem where it wasn't a horizontal asymptote, let's say it was, y equals, 2x plus 4x squared over 3x squared, okay, so we had this. Then our end behavior asymptote, I don't know exactly what it would be, but I know it has a slope of 2/3. So I would have some kind of end behavior asymptote like that. As the curve goes that way, then it's going up. As it goes this way, it's going down. Now, if that had been the problem, then the end behavior asymptote would have this slope. So to the left, it would be going up, and to the right, it would be going down. So the curve is gonna behave like it's a behavior asymptote. That make sense?
Yeah, my question was more approaching from the top or bottom, like, we don't have to do that all if we don't
Only
have
if you have a
to.
picture. Only if you have a picture. Mhm.
Problem D on the Big Ten worksheet.
Okay, I think we did this, didn't we?
Did we?
Oh, we didn't? Oh, no, you're right, I did it with the other class. It's on video, you can see it. The function has a vertical, okay, so first thing I have to do is factor everything. So I'm gonna try to do this right. I'm gonna take a 2 out and factor that. Please stop me if I make a mistake. And then my denominator is going to be x minus 8, x minus 1. Right? Now, what do you notice? There's a hole. And you can find it. You're not asked to find it. You're asked to find the vertical asymptote. Where's the vertical asymptote there? X equals 8. Yep, that's your vertical asymptote.
Then what about the x equals c part?
Well, that's, C is 8.
Oh,
X equals 8.
oh, okay, I didn't
There's asking you, what is that number?
Oh,
How would you write the end behavior for a slant asymptote?
It would be positive or negative infinity. So if it's going up, it would be positive infinity. If it's going down, it would be negative infinity. Yeah. All right, what else? Go ahead, Fred.
I'm out of problems.
You're out of problem.
All the ones that-
You've done a good job today. Thank you. Some of you scoundrels haven't asked a single question. And others have not prepared.
I have a question about limiting factors.
About what?
Limiting factors, and like when it's like the answers too, how do you know when you put a plus sign and a minus sign, please? Like above the number? Do you know what I'm talking
Are you talking about, if I say the limit as x approaches 3 is 2 from the top, somebody, yeah. If you have a picture, you should use that notation.
But how do you know, like, how do you know which one's which? Like, how do you know if you're using positive?
Here's 2, y equals 2. If the picture looks like this, it's coming in from the top. So that would be that. If it looks like this, it's coming in from the bottom, so that would look like that.
Okay.
That means top and bottom. It's not positive and negative, it means top and bottom.
Does x approaches 3 mean that there's a square class?
Yeah, I was trying to make something.
No,
else.
you're okay.
No, there actually could be a hole there also. You could have a hole there.
Oh, and that's when it
Yeah.
like goes to the
Yeah.
same.
Yeah. Okay? All right, well, no one asked, you're out of questions? You got 4 minutes, you're out of questions? Al?
I just thought of this, because of that picture, could a horizontal asymptote or slant asymptote be where a hole is? And you could like
Could the horizontal asymptote go through the hole? A slant can't, a slant won't, because it won't equal the function there. But what about a horizontal? I don't know, I have to think about that. I got feeling it's no, but. Okay, let's suppose we have to find the, fourth term of 3x plus 2y to the fifth. Alright, we're gonna find the fourth term of this. Okay, so here we go. I know that the fourth term, every term, any term, is going to have some kind of a coefficient. In this problem, it's going to have a 3x and a 2y. Did everybody agree with that? Every single term is gonna have that. So I need to figure out what my coefficient is and what my powers are on that, on those parentheses. So I'm expanding to the fifth power. So I would need the fifth row of Pascal's triangle. Now I have that memorized. You do not have to memorize it. You could either calculate it on your calculator, if it's a calculator problem, or build the triangle to the fifth row. That will take you about 10 seconds. I want the fourth term, 1, 2, 3. So would you agree that's the one I want? So that number right there is a 10. Now, if I were writing the whole thing out, using all those coefficients, right here, the power on 3x, right here, the power on 3x would be 5, right? Start with 5 and count down. So 5, 4, 3, 2. So my 3x is gonna have a 2, which means my 2y is gonna have a 3, because they gotta add up to 5. And then, I'm careful, I'm gonna multiply 10 times 9x squared times 8y cubed. Remember to apply the exponent to the 3 and the 2 also. So your answer would be 720 x squared y cubed. Okay?
How did you find that?
Watch the video.
Yeah.
Oh, yeah. What do you got?
Wait, you do apply the exponent to the coefficient?
You apply the exponent to this guy.
Okay, so then when you're multiplying across,
This multiply.
okay, yeah.
All right, have a good day. Don't forget math week's on Tuesday.
What's that one, what's the math teacher do?
Oh, that is so awesome. You're so good at it. Oh, that's wonderful news. That makes my day.